Good morning, friends. Hey, we're on to lesson 710. Last lesson of the unit before the test. Can't get any better than this. All right. As you see here today, hey, it's 17 slides. So you're probably saying to yourself, this must be just a layup at the end of the unit. But what we really do is we really dive deep into things. We make you do a ton of different examples. This is some really heavy stuff here. And so, where I know it's kind of short slides, we do cover a lot. But the good thing is, I think by the time you are done, you're going to have a great understanding on quadratics, how to factor them, how to solve them, so that by the end of this unit, you're going to review and you're going to ace this test. I can feel it. Okay. So without that, let's jump right in. All right. Which one doesn't belong? Okay, so again, these are one of those where there's really no right answer. Or let's take that back. They're all right answers. There's no wrong answer. Okay, all right answers. So we could say, hey, with A, why doesn't it belong? It's in factored form. The rest are in standard. What about B? Well, B has, we look here. It's going to be the only one that has an A value that is greater than 1 out of all the other ones. All the other three, A, C, and D, would have an A value greater than 1. What about C? Well, C's missing what? C's missing a B. So maybe you said, hey, C's the one that doesn't belong because it's missing a B. And then, of course, there is D. And, what do you say about D? It's the only one that has an A, B, and C that's in standard form. And, guys, it's the only one that can't be factored. Hey, there's no factors of 3 to add up to 2. So that's the only one, too, that's not going to be able to be factored. Okay, so let's look at this, guys. Hey, factored form to standard form. Just the reason that we're going to do this is we're going to get some good practice today in doing these. And so we're going to kind of work inside out again, remember? So we're going to try to get used to this. So quickly, hey, 3x times x gives me 3x squared. 1 times x is x. 3x times 4 is 12x. And 1 times 4 is 4. So when I add all these together, guys, I'm going to get a 3x squared. I'm going to have my like terms here, so I'm going to get a nice 13x, and then I'm going to have a 4 on the end. Okay, so what we're going to do is we're going to erase this guy, this guy, this guy here. As we see, instead of now a 4 and a 1, it's going to be 3x plus 2 and x plus 2. So let's see what that gives us. So we got a 3x and a 2, so I'm going to have a 6x. 2 and an x give me 2x. And 2 times 2 is 4. So now for this one, I'm still going to have a 3x squared. Now I got a 6x and a 2x. That's going to give me 8x and then plus 4. Okay. Now, guys, still kind of along this theme here. Try to use this box as much as I possible without ruining it. There we go. I'm going to have a 3x plus 4. Okay, and I'm going to have an x plus 1. So 3x times 1 is 3x. X times 4 is 4x. And 1 times 4 is 4. And so for this one, I'm going to have a 3x squared plus 7x plus 4. Okay? And so that's how we do it. Now, hey, remember, just a side note, if you are a person that foils, you could have absolutely foiled these and would have got the same answers. Okay? And so we should be good to go. All right. So what we've done now is, we've done the standard form for these already. See how this was the 3x plus 1, x plus 4, the 3x plus 2, x plus 2. All those we found. So I'm not going to do these again because we just did them. Now we need to factor, okay? And so again, we showed that. So remember, I'm going to use the AC method. All right, so hey, I'm going to draw my x. Now I'm going to take 5 times 4, which is 20. Okay, AC over B, and then this is a 21, isn't it? Okay, so factors of 20 that when I add them together give me 21. It's pretty tough, isn't it? Okay, well, there's only two numbers that do that, and that's a 20 and a 1. And so we've got a couple options here, and I'm going to show you both, okay, because I know we've shown both of them this week, but there is the box method where we're pulling out, or there is split the middle. So now what we're going to do, guys, is let's draw our box, okay, and here's my box, and remember, I still have the 5x squared here, so I'm still going to have 5x squared. Now we're going to use these guys right here that I found, and so we know that this is going to be my 20, and we're going to put an x with it. This is going to be my 1x, and then we need to use our c, which is the 4. And so let's pull out like terms. I like to pull out from the rows. Okay, and so 5x and 20x, what do those have in common? 5x. Now, what does x and 4 have in common? Just a 1, right? So then you need to ask yourself, hey, 5x times what gives me 5x squared? Well, that would be an x. And 5 times what gives me a 20x? Well, that would be a 4. Okay? And so now I see that, hey, 5x plus 1 is one of the factors, and x, and since this is a positive 4, we would say x plus 4 is the other. Okay, so now let's do this again. So I'm going to use the AC method. So I'm going to take 3 times 12 and get 36. And then I have 15 down below. Okay, and so this one, again, guys, we're looking for those that add up to 15. Kind of a difficult one. You know, for me, the first things I think of is like 4 and 9, but that's not going to get it for me. And so we also know that 12 and 3, if I multiply those together, I'd get 36. If I add them together, I would get 15. So we draw our box. Okay, I don't touch the 3x squared, and I don't touch the c, which is 12. And what we're going to do now is we're going to plug in the two numbers that I found to give me my angles. Okay, and so do that. So again, guys, maybe I'll change colors so that we can see this. This 12 and this 3 is this 12 and this 3. And so now I'm going to pull from the rows to see what do I have. So 3x squared and 12x, those have a 3x in common. What does 3x and 12 have in common? 3. Now we see what multiplied to get those. So what times 3x gives me 3x squared? X. And what times 3x gives me 12x squared? 4. So let's see. Does that also give me this one? 3 times x is 3x. 3 times 4 is 12. We're good. Okay, so I'm going to have 3x plus 3 and x plus 4. Now, hey, by the way, depending upon how you started pulling those out, you could have gotten x plus 1 and 3x, I'm sorry, 3x plus 12. That's another one that you could have gotten. Okay. Let's do this next one. We probably haven't done enough of this, but let's try factoring by grouping so that you kind of see both options. Like, I like the area model. I think it's good for you guys, but let's also do factor by grouping. So 6 times 10 is 60. Okay, and then I get a 19 on here. And, the 19 stumped me for quite a while. But then I realized, oh, hey, it's 15 and 4. Okay, We know they're both positive. And so, guys, the fact by splitting the middle, this is what this looks like. So I'm going to go 6x squared, and then we're going to bring these in, plus 15x plus 4x, and then this very last one here, which is 10, so plus 10. Okay, so this is what I got. So now what we do is, the reason it's called, we pull out what these two have in common. So 6x squared and 15x have a 3 in common, right? And so then I'm going to get 2x plus 5. And then I say, okay, what does 2x and 10 have in common? Well, they have a positive 2 in common. And I'm sorry, this should have been a 3x. I know it's tough to see. I'm sorry. No, I can't do it. That is not appeasing. And so I know I already write bad enough to see that. So we at least need to make it look a little presentable. There we go. And this is going to be a 2, and it's going to be 2x plus 5. Notice what's in prime parentheses is the same as it should. Okay, and so we're going to take the numbers that are outside and form one of the parentheses. Okay, and then what you do notice then is, hey, I'm going to take this parenthesis that I already have, and that becomes my second factor, 2x plus 5. Okay, so you can use either method, the area or this method. Does not matter which one you use. I know it does seem, both probably do seem a little slow using it on the computer, but the computer forces me to write slower. Once you get paper and pencil in hand, you should be knocking those out. No problem. Okay, here's 3 quadratic equations, each with 2 solutions. Find solutions to each equation using the zero product property somewhere along the way. Show each step. We're going to go ahead and we're going to skip this slide for time purposes because it doesn't give us a spot to solve those. Okay. So, an engineer is designing a fountain that shoots out drops of water. The nozzle from which the water is launched is 3 meters above the ground. It shoots out a drop of water at a vertical velocity of 9 meters per second. And so here is the model. So we know that, hey, the negative 5t squared would be the pull of gravity in a downward direction. The 9t is that vertical velocity. And then the 3 means that it's shot 3 meters above the ground. So how many seconds until the drops of water hit the ground? So first we need to write the equation, correct? So we need to know, hey, when does negative 5t squared plus 9t plus 3 equals 0? Because that is, we want to know, hey, when does that give me a 0 for my equation? Okay, so now, we need to try to write it in factored form and using the zero property. So I'm going to go ahead and I'm going to say, hey, negative 5 times 3 is a negative 15. Okay, and so then when we do this, I'm going to get a 9. Okay, good there. Okay, and so what are multiples of 15, negative 15 that when I add them together give me a 9? And golly, right now, I can't I can't think of anything. And so, so we've got to try to write this factored form using the zero product property. So I can't think of anything right now. Hey, you've got 5 and 3, 15 and 1. So we couldn't use this right now. What we can do is we can try to solve it by graphing it. Okay. So we've got the negative 5 x squared minus 9x minus, and I believe it was plus 3, right? And so, and actually, this was a plus 9x, wasn't it? Let me just double check there. I forgot about that. That was a plus 9x. Okay, so there we are, guys. So we see here, as I look at this, that we shoot it from our, our platform here at 3, 0. And the reason, guys, we couldn't find those factors is because they're not whole numbers. And so we've got a negative 0.287, which is our irrelevant, the 287,000 right there. But we do have, what, roughly 2 and 87 thousandths right there. And so that's going to be, when we hit the ground, is that, let's round up to 2 and 1/10. Okay. So how did you use the graph to find the number of seconds until the, well, we used the x-intercepts to help us find when the water hits the ground. Okay. So now that's, how we can use the graph again. So when in doubt, you can graph it out and solve that way. All right, now this right here is pretty clever. I like what they do here. And so, we need to write it in standard form as equivalent to the 9x squared plus 21x plus 10. So first, let's do that, okay? Let's see. So let's take 3x and 2. Let's do our square. And I'm going to get 3x and 5. And I apologize for my handwriting in advance now. So I'm going to get a 9x squared. 3x times 2 is 6x. 3x plus 5 is 15x. And 5 times 2 is 10, right? So when I add this together, I do get a 9x squared plus 21x plus 10. Okay, there we go. So now, this is what I love about this. So they see, hey, this a here we see is a perfect square, and b is also divisible by that perfect square, so that 9x squared. So, hey, we know that 9x squared is really 3x squared, right? So because 3x times 3x would be a 9x squared. We also know that 20x is really 7 times 3x. So see how they put it in parentheses? This is so cool. So now what we can do is, instead of saying, hey, instead of 3x, let's treat that as n. Almost like, hey, this is my number. We know that. So now what we get is, instead of getting this tricky a is greater than 1 hard problem to factor out, we now have n squared plus 7n plus 10. Well, that's easy. Factors of 10 that when I add them to, multiples of 10 that when I add them together I get a 7. 5 and 2. So I get n plus 2, n plus 5. Now hold up. We know what n is. N is representing 3x. So let's plug the 3x back in, and I get 3x plus 2, 3x plus 5. You just found out that is equivalent expression based on we checked our answer. Okay? I just explained the thinking there. So we do that to make a equal 1 to make it easier to factor and to solve. Okay, so now let's, enough of just trying to explain it. I think it's easier for me personally if we just dive in and try to get it. Okay, so I got 4x squared. No, it's a terrible 2, sorry. 2 is x squared plus 28x. I like how I think that 2's better. Holy moly. Plus 45. Okay. So here's where I'm at now, guys. And so what we say is, hey, what is 4x squared? Okay, what number is that as a square, as a perfect square for that? So 2x squared, the square root of that is 2x. So we're going to take that 2x squared. Notice that the 2 is on the outside of my parentheses. Plus, now since we took this divided by a 2, guys, we're going to take this 28x divided by 2x. And what do I get? Okay, we're going to half it. 14 times 2x. Okay. And now notice I did nothing to the to the 45, did I? No, we leave it. Okay, so now since we know that both have a 2x in it, we can use a placeholder for the 2x, and that's this capital N. So now I'm going to have n squared plus 14n plus 45. Okay? And then from there, it's easy because a is 1. So I'm just looking for factors of C that add up to B. So factors of 45 that when I add them together give me 14 would be a positive 9 and a positive 5. Okay, so now I have these, and now the last step, ladies and gentlemen, is we put that 2x back in as a place, because n is just a placeholder. So my final answer would be 2x plus 9. Sorry about that. My writing is getting a little sloppy. 2x plus 5. Okay, so see, we put a 2x back in the placeholder of n. Okay, so now I've got a 25x squared plus 35x plus 6. So let's try the same thing. So again, hey, 25x squared. And start to think about it as we're writing this out. Okay, what number times itself gives me 25? Okay, well, we know the square root of 25 is 5. Does 5 go into 35 as well? Sure does. Okay, so what we're going to do now is I'm going to make my parentheses and make this a 5x. Because 5x squared is 25x. Okay, now minus, hey, 35 divided by 5 is a 7. And this is going to give me a 5x. Okay, and I don't touch the 6. Never touch it. Stays there. There we go. Okay. So now, instead of having 5x, we want to use that placeholder. N squared minus 7n minus 6. And so now I'm looking at, actually, guys, thank you for correcting me. This should be a plus 6. And so now I'm looking at factors of 6 that when I add them together give me a negative 7. Well, we know then that could be n minus 1 and n minus 7. Okay, let's see. When I multiply those, take that back. 6. There we go. Well, when I multiply those together, I get a positive 6. When I add them together, I get a negative 7. There we go. Okay, so now the last step that I do is I plug in the 5x into the placeholder. So I'm going to have 5x minus 1 and 5x minus 6. There we go. All right. See, aren't these fun? I think these are nice little puzzles, Okay. So, here's another thing that you've noticed in all of these was, so what if the coefficient's not a perfect square? What do we do to get it to be 1? Okay. And so what they do then is, to make it a perfect square, take it times that 5 to make it a 25x, and you can use the placeholder. Now, we got to at some point get that back down, and so what we do is we're technically multiplying by a 1, because we're taking 1/2, or like this did 1/5 times 5. We know those together equal 1. We're breaking it out. We're just going to multiply by 5 at first, then we're going to multiply by that 1/5 at the end to take care to reduce it. Okay, still get an equivalent expression, and so it just adds to a thing. So show your reasoning. So to use the distributive property to expand this. So let's take the x plus 3, okay, and the 5x plus 2, and let's FOIL. So x times 5x is 5x squared 5x times 2 is a 2x. 3 times 5x is 15x. Okay, and then 3 times 2 is 6. Okay, then doing so, combining your like terms, 5x squared plus 17x. Sorry, 17x plus 6. Okay? All right. So, using this, guys, I mean, you can look at this. I'm not going to really tell you how to do that. You know, I mean, for me, hey, if I use the AC method, you know, the good news is you use the AC method, you're going to get a 30 over a 17, right? And so you're going to know that it's 15 and 2, which, you know, hey, you're getting down into this area here, and so it's going to, you know, you're going to get it, okay? It's going to happen. You're going to get down to that x plus 3, 5x plus 2. So don't worry about it really from this standpoint. I would not do it with this. You know, hey, it says to try your hand at 3x squared plus 16x plus 5. But again, guys, you know, if that's what we have, I know that this isn't the right way to do it. You know, hey, it's teaching this, but just take 15, okay, AC over B, 15 and 1, okay, those are going to multiply to 15, they're going to add together to give me 16, and then from there, guys, just again, you know, for me, I was only privy to this type this year, never had done the area model when factoring. I had some students here, shout out Miss Beamer, those kids had her, and they love to factor like this. And then from then on out, guys, I'm like, well, do I need to do it another way? And, you know, I mean, of course you can split the middle and stuff like that. But I mean, this guy's just is so visual. I think it does a great job. And so again, let's say 3x squared and an x we have in common, well, just x. And then 15x and 5 have a 5 in common. So x times what gives me 3x squared? 3x. Let's see, does that 3x times 5 give me 15x? Yes. And x times that, 1. 1 times x is that, 1 times 5 is that. So again, guys, we're going to have x plus 5 and 3x plus 1. Okay. So we can do all that jargon on the left, but I feel like, hey, let's just keep it simple, know what we know best, let's keep it in our wheelhouse, and let's just do it how we know how. Okay. Now, this one, you know, you would think is a little tough, you know, but again, guys, let's keep it in our wheelhouse. For me, I'll split the middle this time just to give you the different sets. So A times C, which is 40. Okay. B is negative 41. Hey, what gives me a 41 if I add them together, but when I multiply them together, I get a 40. Negative 40. And a positive, oh, I'm sorry, negative 1. When I multiply it, it'll give me 40. When I add them together, I get a negative 41. So take these guys here, okay, and then split the equation. So I'm going to have a 10x squared minus 40x minus x plus 4. Okay. I'm sorry. I need to rewrite this better. So minus 40x minus x plus 4. Okay. So what do these have in common? 10, right? And I'm left with x 10x, what they have in common. And I'm left with x minus 4. Okay, these guys have nothing in common, so we'll just do a minus 1, because there's that negative. Now remember, when I'm dividing these by a negative 1, I'm going to have an x, and then it turns this positive into a negative. Okay, alright, next thing we do, okay, I got these guys, the 10x and the negative 1. That's going to be one of my parentheses, 10x minus 1. And then I've got my other, which is the both parentheses. Those come together to just give me 1, x minus 4. So, all right. Okay, we did it, guys. We are done with the first part of Unit 7. You are now ready to be assessed on the first 10 units here. So your next class period, you'll do the review, and then it's test time. Okay, so by now, guys, you should know how to factor these. I know you're in a great spot. I know you'll do great on the test. If you are struggling, please reach out to your teacher. Take responsibility, take initiative, reach out to them, hold yourselves accountable, and hold yourselves to high standards. With that being said, ain't nothing to it but to do it. You got this.